All right. So good morning. It's Monday morning, May 6th, and I am going to go ahead and go over some of the commands briefly reviewed that I briefly reviewed in Thursday's lecture. Right near the end, we didn't quite get to the commands, but wanted to go ahead and dive in and share some of these commands. As an IT professional working in Linux or perhaps other operating systems, you may encounter these commands. But I wanted to go ahead and just demonstrate a few of the commands that we use when we're troubleshooting network issues. So the first command is ping, and more than likely you've used this in previous classes, be it IT114 or IT131. Ping is basically going to establish that the remote host is live. It could be a server, it could be a router. It wouldn't be a host if it was a router, but the end point that you're pinging is up and alive. So for this demonstration, I'm going to use our old friend at 8.8.8.8. It's a Google DNS server. So 8.8. Oops, for me. Okay. And we can see here that pings are being returned. Now, one thing to note in Windows, when you do a ping, it defaults to 4 packets. It'll send 4 packets, and hopefully you get those 4 packets back. In Linux, that is not the case. It will ping until you tell it to stop if you don't tell it how many packets you want to send. So let's use the -c parameter. That's going to be a dash and then a lowercase c, and we'll do 20. Okay. All right. And you can see that it took about 19 seconds to complete 20 packets. All right. So the next thing we want to do with this, let's change this to 10. And then oftentimes one of the things that we want to do is make sure that packets are getting through of a certain size. All right. The typical size here, let's see if it tells us 64 bytes. Okay. So that's a really small packet. So let's go ahead and change our size to 1500. Okay. Okay. So we can see here that it's not going to allow 1500. So something somewhere is stopping it. Most likely it's on my side here. You can see that it sent 10 packets, 100% packets. Let's shoot the middle and go 700. 750. Okay. Okay. So it didn't give us the time, the time back and forth here. You can see that it gave us the ping time. It truncated the output here, but the packets were sent and received. We had 0% packet loss. Okay. So what that means is our MTU size is somewhere between 1500 and 750. I'm gonna go out on a limb and say that it's let's do 1491. Oh, okay, that's not gonna work. Okay, so somewhere between 1400 and 1500 is the limit. Okay. And I'll let you experiment with that. I don't want to take up time here in the virtual lecture, but you can see that the MTU size is somewhere between 1400 and 1500. The MTU size being the maximum packet size. Let's Let's go to Google. Typical MTU size. Whoop. Hmm. Okay, so really quickly here, this says 1452 is most optimal. Oh, you know what? Let's do this. Let's try again. Okay. Hmm. Okay, so 1452 worked. Okay. Uh, so you can see here that 1473 does not work. And 1472 did work. Okay, so the maximum amount of data, excuse me, the maximum amount of data that we can pull inside a packet is 1472 bytes. When we do 1473, we get packet loss. Okay, let's try one more thing. Let me turn my VPN back on, and we will redo that. Give it just a minute to establish here. In fact, let's do this. Hmm. Actually, this traffic's not going through the VPN anyway, so it doesn't matter. All right. So we've demonstrated the ping. Oftentimes, we want to use bigger packet sizes to troubleshoot either latency or jitter issues. Um, Latency being, hey, it's taking longer than normal for packets to go across a path. Jitter would be a fluctuation in traffic. We most notice jitter in streaming applications or VoIP telephony, where we're seeing packet loss. We can hear kind of the can you hear me now? The phone call breaking up. That's where we're going to see issues with jitter affecting the service. So something to keep in mind. You will use this at some point in your travels, either from a Windows machine or a Mac OS box or a Linux host. So remember, and it'll vary from OS to OS what the parameters are. In Windows, the count is n. So I can just demonstrate here real quick. 8.8.8.8. And here I'll just show you real quick. It's going to default to 4. Okay. And if we want to do count, we'll do 15. And you can see and again, we use the ping command to establish that the host at the other end is alive. We can also use it to identify which hop in a path, which router hop is problematic for us. All right. See, I think Hmm. Hmm. All right. So we've exhausted ping. There's some other parameters that you can mess with in ping, but those are predominantly the ones that you're going to use: size and count. Okay. The next one I want to go back and review actually is ifconfig. Okay, so very similar to your IP config. But again, here you'll note here's our interface. Now, a couple comments about the interface name. I am running a virtual machine, excuse me, a virtual machine through Oracle VirtualBox. So it's not going to say ETH0 or ETH1. If you're running Linux on a physical box, not on top of a hypervisor uh, or Oracle box, something that's providing you that VM. If you're not running it directly on a server box, you're gonna get something like this: a little bit of Greek, something that's a little bit counterintuitive. If you're running it on a server, bare metal is typically what we'll call that. If you're running it on bare metal, you will see the ETH0 or ETH1. Sometimes on the back of a larger Linux server chassis, you'll actually see what looks like a switch, multiple Ethernet ports on a line, and sometimes there'll be copper or J45 jacks. Sometimes nowadays you'll see fiber. So just depends. All right. A couple things here to note. My interface is up. Okay, it's going to allow us to do broadcast, multicast. Here it says the MTU size. So something to keep in mind, you'll remember that Ethernet operates at layer 2. So this is the maximum frame size. Okay, so that includes the frame header and the frame footer. Okay, which has the frame check sequence. Here's my IPv4 excuse me, IPv4 IP address. Okay, 192, 168, 111, 61. Okay. And then my IPv6 address here, and then my MAC address. And this is assigned by VirtualBox. Remember, there's no hardware here. So actually, if you go into VirtualBox, and let me find a host that's not running. We'll just go here. Okay. You can go into settings and go into network and click on the blue arrow. And right here, you can actually change this setting. So I will, let's see. Let's go ahead and do this. Let's do this. Let's change this to AA. Let's make sure I didn't delete too many. Okay. So let's go ahead and start this virtual machine. And while that's coming up in the background, I'll come back here. The rest of the information is our packet counters or our X packets, how many packets have been received on the interface, how many packets have been transmitted. Okay. And you can see that the packet counters have increased. The loopback interface right now is configured to 127.0.0.1. And remember that this IP address, this 127 IP address, is reserved for the local host. So we can ping this to make sure that the IP, the connection stack, or what we call the TCP/IP stack, is up and running. Okay, and then the IPv6 IP address is all zeros and then a 1 at the end. So 127 zeros in binary and then a 1. Okay, remember that IPv6 is 128 bits. And all right. So you will also use this command quite a bit in your server administration travels. All right, so we did ping and we did ifconfig. The next one we're going to look at is traceroute. Okay, so this is going to give us a hop by hop path to our destination. We'll use 8.8.8.8 again. Oops, we got to install it here. Okay, and actually, while that came up, while it installs, let's just go over here real quick. This is our host where I changed the MAC address in VirtualBox. So I'm just going to demonstrate that I'm able to change the IP address, the MAC address. So let's just go ahead and do our config command. Okay, and you can see here is the MAC address. Remember, it said I believe 05, and I changed it to AA. And one thing to note here, when I changed it in VirtualBox, it was using capital letters, capital A, capital B, capital C. Here it's using lowercase. MAC addresses are not case sensitive. Remember that they're stored in hexadecimal, and that the digits are 0 through 9, and then A, B, C, D, E, F for base 16. Okay, so if you have any questions on that, let me know. Shoot me an email or take time to review your IP subnetting, IP addressing from 131 or 114. All right, I'm going to go back to my other virtual machine. Traceroute has installed. So let's go ahead and do our traceroute. And you can see here's my gateway at home. Okay. And then here is the first hop router outside of my network. Okay. So here's my gateway. This is the IP address that is giving, or the device on my network that's giving out IP addresses. Okay. Here's the first hop outside of my network, 152.44.216.2. Okay. And let's take a look at something here. So I'm not going to post this on Canvas, but if you can send me an email with the name, either the current name or the former name of my internet provider here at home, here in my house, who my internet provider is, I will give you 10 points, 10 extra credit points here. So I will leave this up here for a moment, but you should have all the information in front of you that you actually, excuse me, you have all the information you need to do this. I will put a space holder in Canvas. We'll list this as CTF event 6, I believe it is, and it will just be called scavenger hunt. All right, and so just email me with the answer, and I will award you 10 extra credit points. All right. The thing to note here is this is the path that the packets took through the network. And every once in a while, you will encounter what's called asynchronous routing. So, which can be problematic. You could have a scenario where traffic works in one direction and not the other. For example, you could have traffic that goes from Seattle to Denver to Dallas, and that works fine. And then the return trip, excuse me, I have something in my eye. The return trip might go Dallas, LA, Seattle, and somewhere in the LA data center, there's a special firewall or some traffic device that's restricting traffic. So it could create issues. And traceroute's going to give you an insight because the traceroute one direction might show Seattle, Denver, Dallas, and the traceroute from Dallas to back to Seattle will show Dallas, LA, Seattle. Now that's very high level. It's okay, but traceroute is a very handy tool for making sure that you understand the traffic flow from point A to point B, from your host to the end point. All right. All right. The next command you remember from uh, other classes, hopefully, that you have DNS, right? DNS is domain name system, right? And in the domain name system, basically what we're doing is taking something that's human readable, like www.google.com, and DNS converts that to an IP address. Okay, so let's just take a look at again. We'll look at 8.8.8. Okay, and you'll notice here that it doesn't actually tell us dns.google.com. Let's go ahead and flip this around. We can actually go dns.google, okay, and we can go google.com, okay, and it actually gives us two. Gives us 8.8.4.4 and 8.8.8.8. So it gives us two options. And let's see. Let's do one other one. Okay. Let's do nslookup. Okay. 128.95.120.1. Okay. Okay. And this is the DNS server for the University of Washington. Okay. I used to use this host and still do sometimes. I used to use this host sometimes to just make sure it had internet connectivity because it's highly reliable, right? Should be available all the time. So I just ping it because I had it memorized. Um, all right. In fact, it's probably the first IP address I memorized. Okay, let's see. All right. The next command I want to go over is tcpdump. Okay. And really quickly, this command is resource intensive. Okay. It takes up disk space, it takes up memory, and it takes up CPU. So when you do it, you want to make sure that you know what you're doing. Okay. So let's just see. Let's look at the man page first, the manual. Remember, we can usually type man TCP dump, okay? And this says no entry for TCP dump, which is strange, okay? What that really means is it's not installed. All right, so take a moment and install it. I'll pause the recording. Okay, so I have a TCP dump installed. I'm going to go ahead and look at the man page for TCP dump. Remember again, man stands for manual. So you just do man and then TCP dump, and you're good to go. And there's a ton of options here. Perhaps this right here, this dash C and then count. Yeah. So a couple things here. I just want to go over TCP dump. Again, TCP dump has a number of parameters that you can use to filter on. So really quickly, I'm just going to do a quick demonstration here. Okay, so we can do use the dash I parameter to specify the interface that we want to model. So remember, if we don't remember what our interface is, we go to ifconfig, and this is the one that we want to look at. emp0 s3. Okay, let's go ahead and do tcpdump -i emp0 s3. Okay, so let's go. Oh, now remember, I mentioned that, hey, this is a command that can cause some resource consumption, so we want to go ahead and use sudo. Okay, and again, this is going to go until we tell it to stop. Okay, so it's picking up packets. All right. So the next thing we want to do, let's see here. What was our IP address again? Okay. Okay. So you'll notice in here that there's several different IP addresses here that are coming in. So let's go ahead and try to, first of all, we're gonna only get a few packets. We don't want a whole lot. So to do that, we use the -i parameter to specify the interface. We're going to use -c to do a packet count. So let's just capture 10 packets. All right. And here we go. And you can see here that first of all, we didn't catch a whole lot of stuff, and it doesn't look really interesting. But let's go ahead and do this. Let's up arrow, and we're gonna add what's called verbosity or verbosity. Okay, we want more information. Okay, so let's take a look here. Okay, so we got a little bit more information. Um, let's do this. You can also specify the buffer size. Uh, this is how much information we'll capture. File size, how big the file is. If we want to save this information to a file, oftentimes when we do a TCP dump, we're doing it to troubleshoot some problem, and unless we are the sole troubleshooter, right? If we're on a troubleshooting bridge with perhaps we're tier two, we've got our tier three, or we have vendor support on the call on the troubleshooting bridge. We might save this to a file, send it off to tier three or to vendor support, and then they'll analyze the packet captures. This is called a packet capture. They'll analyze the packet capture, and then let us know what's going on. Um, so let's see here. We want to get rid of the resolution. Okay, so you can use it. See, we can use this -n. Let's see. Don't convert addresses. Let's do this. Let's run our dump again. Let's do the simple one first. Okay. And let's just see what happens. Yeah, okay, here we go. Okay. The one thing that we see here, or we don't see here, is any traffic, anything indicating our own IP address. Remember, this IP address is actually my, what I might call my bare metal, right? It's my laptop's IP address. Oops, it's actually not even that. This is actually my well, I'm not gonna tell you what it is, but it's a host on my, it's a quasi statically assigned IP address on my network. And this dot 46 is not. So we need to filter for an IP address, the source IP address. Oh, okay. So what we need to do is we need to filter on our host, which is 192.168.111.61. Okay. And let's see what happens now. Okay. So as soon as I loaded up the browser, it started generating traffic for us. Okay, so let's take a look. Here we have our source IP address, which is my VM. Okay. And we sent a DNS lookup for, okay, so we did DNS lookup, port 53 remembers DNS. And one of the interesting things, one of the things that I've always thought was neat is that DNS traffic can either use UDP as a transport layer or TCP. And go back to your networking class, to or networking notes to remember UDP is basically best effort. TCP is connection oriented, right? We're gonna establish a connection. Okay, all right, and you can see here that now some traffic came back, some web traffic. Here's 443, right? So 142, 251, 33, 110. And we can see that here. If we go here, we can look, click here. Oh, okay. It didn't tell us what page it went to. All right. Let's see. All right. But you can see that it's on HTTPS. That's the 443 port. And then the local port was 46,582. Okay. All right. So just to give you an idea of what TCP dump will do, we could run that again. Let's do it again and increase the verbosity. Okay, and again, I'm just going to capture 10 packets. Okay, so let's do www.google.com. If we can get it there, I think it already timed out. Yeah. Okay, so let's do this. You see how quickly it captured 100 packets. So what I did here, I'll just explain this really quick. Remember that when we run a command and then use this greater than right angle bracket, or excuse me, yeah, the left right angle brackets, excuse me, um, that it redirects the file to an output file, right? So when we use the greater than symbol, we're saying, hey, take this program output and put it into a file. I don't want to see it in the command line. It's going to make me confused. So let's go ahead. We've already done this. Let's go ahead and just look at that file. You can see that 17,941 bytes. That's not too bad. Let's go ahead and cat that file. But I want to do more. Okay. Wait a second. Okay. Hmm. All right. Hmm. Just one more time. I don't know if we can do. Let's just show this. All right. Not getting the level of detail that I want. All righty. We'll do it. You know what? We'll come back to TCP dump. Let me do some offline troubleshooting instead of taking up a bunch of time here. The point here is that TCP dump is going to be used to grab uh, PCAP information or packet capture information off of a Linux host. Typically, we're looking at what's going wrong with an application or database connection. Um, and a lot of the times, you're going to be handing off this file to somebody else that wants to look at it or see what's going on. So, all right, definitely not your morning light reading. All right, the next command I want to demonstrate here. Let's go to our Python website here. Python download, and in one of the upcoming labs, you're going to download, and these labs are old. You're going to download Python 2.7. Okay, so find Python. Let's just do 2.7. Next. I believe it's 2.11. You're gonna go here and you're gonna download it. Let's okay. So what you're gonna do, you're gonna download this file right here in the lab. You don't have to do it now. But it's called a gzip tarball or gzip source tarball. and I'll talk about that in a moment. But what I want here is the link. Notice the link here is www.python.org/ftp/python, the version number 2.7.11, and then python-2.7.11.tgz. Now, one quick note, I realize this is early and probably premature. I make this note in the walkthrough as well, and I'll try to remember to mention it in lecture. The lab, this is one of those instances when you download this, you want to slide that bar over to the right because it actually cuts off the word Python, or it can, and you'll end up typing just the 2.7.11 slash and then 2.7.11. It doesn't show the Python if you have it set to the defaults, possibly. So just be aware of that. Um, the file name includes Python. All right. I don't think that I can actually. Okay. So what we're gonna do wget and then HTTP. Try to download this HTTPS www.python.org. We're going to do FTP, Python 2.7.11/Python. So what it allows you to do is either download a file or download the page code. So in this case, we downloaded a file. Maybe we want to install this file or use this file. Um, well, so wget, basically it's wget. And again, there's a man page for it. Okay. WebGet or wget is a free utility for non-interactive download of files. Basically, one direction. Where we're downloading the file, we're not doing two-way communications. We just need information flow from the web to our host. All right. Oh, yeah. Let's do this. Let's try this. Wget. Uh, okay. Let's do this. Robots.txt file is the robots.txt file is on web servers. I'm not going to say all, but it's what indexing sites like Google look at what directories a website will allow them to index. Let's go to Google. Okay, yeah. Oh, wget https Nike.com and then robots.txt. Okay, list out. Let's do cat robots text.1. And you can see that they have created the Nike check mark here as their robots.txt file. Okay. So oh, and they have okay, so they have their list of directories that they allow and disallow. Okay. Uh, and sometimes if you're gathering OSINT or open source intelligence, this can be a handy tool. The robots.txt file. It tells you where they don't want you to go. So just kind of remember that for your pen testing and ethical hacking adventures. Don't go making people mad, getting yourself in trouble. But something fun to look at. Robots.txt. Let's find one other one just for fun. Mm, Yelp.com. Okay, let's do Yelp.com. Okay, so it has Asimov's three laws are in effect. Okay. So you can again some of these Starbucks used to have a really cool one. It had a long coffee order. It took up about two full lines. I may try to find it on the Wayback Machine, but yeah, something to have a little fun with. Let's see. Alrighty, last command host. Okay. So this will let's see. Let's do host dash list. Oh, so the host command also gives us some information that we could use for enumeration, basically identifying what hosts are in a network. This would be a good command for our OSINT gathering. Let's do our own host here. 0.0.1. Okay. All right. And so that is our local host IP address again for the stack 127.0.0.1. And another way to remember the local host IP address is that it's the end of it's .1. Okay, it's the first host in that network. The other way to remember it is that it's the nearest power of 2 minus 1. Okay, so it's the last 8-digit number that in binary, excuse me, last 8-digit number in binary that starts with a 0. Okay, so 0 1 1 1 1 1 1 1, right? 0 followed by all ones in that octet. Okay, that's one way to remember it. All right, let's do our own IP address and just see if we get something different here. Do a little experimentation. Okay, so you can see that we got a little bit something different here, right? And one thing to notice is that it puts the octets in reverse order. Okay, so kind of from most local to most remote. All right. Let's do one more remote host of interest. Let's go www.greenriver.edu. Okay. And 134.39.101.95. Okay. Let's do, maybe we can just do Green River. So, okay. So if we were a social engineer, we could hypothetically use this information. This tells us that Green River uses Outlook.com or uses mail protection, provided by Outlook, Outlook.com. The college probably uses Office 365. Now, an interesting note: I'm a student myself at a university, and I actually got a phishing email a few weeks back, right in the middle of winter term, and it basically said, "Hey, your office account is going to be deactivated if you don't fill out this form and turn it in." And it looked really legit. It was from an email address at the college, and it had all the right information. It looked legit, sounded legit. All the spelling was in place. So very, very real looking email. And so you just got to be careful. But from the OSINT gathering and phishing side of things, this could be really useful information. So something to look at. All right, one more command I'm going to work with here is the dig command. Very similar. Let's go and look at dig. Okay, dig is a flexible tool for interrogating DNS name servers. So remember that the name server is the server that we look at that we're sending the request to. Okay? All right. So let's go ahead and do a dig. Okay. Let's go ahead and dig. Uh, let's just go ahead and do dns.google.com. Start with something easy. And you can see here that we have some interesting information here. Okay. And one thing to remember when you're running these commands, they are not they're not passive. They're active commands. Remember, OSINT can be active or passive. So passive means you're on the internet. You might be looking at somebody's LinkedIn profile or their Facebook profile or Instagram. You're gathering information, but you're not really leaving an indication that you were there, at least not on an operating system level, right? Uh, but with these commands, the whatever you're hitting, whatever server or host you're digging or querying, uh, there's a record. Okay, so you want to just be mindful of that. You don't want to get yourself in trouble. All right, and if you don't know what you're doing, don't do it. All right, let's do. Actually, let's go back up and look here real quick. So let's do a dig on Nike.com. One thing to notice here is that it says authority 0. So it's still a correct answer. What it's saying is this is not the authoritative server. This is not the server where this DNS record is established or initially created, right? Somewhere there's a DNS server out there that says, hey, www.nike.com uh, resolves to this IP address, right? And so that would be the authoritative server. If I'm a web server administrator, okay, and I go in and I say www.geoffhart.com is going to resolve to 1.1.1.4, right? That would be the authoritative entry, right? So if you have typically, if you're creating a website through something like GoDaddy or AWS or Azure, they're going to handle that for you. You just put in what you want as the domain name or the subdomain, and they will enter all that and take care of that. But they create that DNS entry, the authoritative DNS entry, and then the DNS that DNS entry propagates through the internet. It's actually kind of a cool process. If you ever get the chance to actually do that, I would highly recommend it. It's a great learning experience. All right. So in this lecture, we have covered ping. We reviewed ifconfig. We also reviewed ping. We reviewed ping and ifconfig. Went a little deeper those. Traceroute. We talked about host, dig, wget, tcpdump, and ifconfig. Okay. So those are some of the networking commands that you're going to use throughout your travels as an IT administrator, a Linux system administrator. So definitely take some time to get familiar with those commands. They will serve you well in your travels as an IT professional. All right, I'm going to wrap up this lecture, and I will do another lecture later this week. Another virtual lecture later this week.